Hello, let's start with our today's DSA journey with this amazing visualizer by dsa.chaicode.com. Use this link to get a 7-day free trial. Let's start with our today's journey. And today is maximum window substring. A minimum window substring. Smallest window of S covering all of T. Given a string S and T, return the smallest substring of S that contains every character of T. Counting multiplicity, if no such windows exist, return an empty string. Okay, so the question says we are given two strings, a S and a T. A S and a T. We have to find if this element, this string, this T string, which is T, is already present here or not. In any substring, of this current string, does ABC present? Actually here present. B, A, N, C, A, B, C, these three characters are present in this range. So it is a valid one. This is our target. We have to find the substring and return the substring like B, A, N, C. You have to return the string also. So clearly says given two string S and T, length of M and N respectively, return the minimum window substring of S such that every character in T include duplicates is include the window. If there are no such substring, return a empty string. Okay. So how could we do this? There is a simple approach for doing this using map and sliding window. Using map and sliding window, first we calculate all the values of T. Okay, then check in the S that if the value of T is present or not. So our target is this. First we have to calculate the string or the substring which contain the value of T. So first start to build a counter string or a map which contain A1, B1, C1 because in the previous case our T is ABC. So here we need A1, B1, C1 from T. Okay. Now start from the left where add every element to 0. How much A we need? 1. Actually in the previous this is our need. We need 1A, 1B and 1C. Okay, so first started from 0, we get 1A. Yes, we need to have 3 condition but still we fulfill only 1. Okay, next D is not in T. Let's go to B. So 1, yes, we need 1B, we increase. A, window count 2, need 1, doesn't meet anything, already satisfied the condition actually. Then go to N is not in the window, so stay there. Now go to C and we have complete everything. Okay, now in this between left and right we have the string ABC. Okay, but now we have to minimize it to find the minimum length. Okay, this is the maximum length, the whole string is the maximum length. Now remove the left, is it is a valid one? Yes, it is a valid one. Remove the left again, is it a valid one? Yes. Remove the left again, is it a valid one? No, we don't have B in between left and right. So this is our final answer, and this is actually the thing we are trying to match. Expand the window until it contains everything you need, everything we need in T, we have to make sure at the start we have everything here, like from left to right we have everything. Then shrink it as much as possible without losing any required character. So we have to shrink this every time. We have to shrink it every time till we got to the minimum length which satisfied the condition. Okay, clearly mentioned in this code here. This is the thing we are trying to expect. Expand the window until it contains everything you need, then shrink it as much as possible without losing any required character. Repeat this process while they keep track of the smallest valid window. Same thing we are doing here. First we just count the element, then we just take one, start the loop. If it meets the condition, have plus plus, or when it matches the condition, remove the left and drop the value. Same thing. Okay, same thing here, which we actually proceed here. So at first we are taking t, which is nothing but at first we are taking the t and store it in a value. Then we are just checking everything to ensure at the first that the string t everything is covered. Now we just increase the left and check if we got any string which is minimum, then we have to find it. If we got any string which is minimum substring and till contain every value of t, we just take it because we have to consider the minimum one. Okay, so let's write down the code here. This is actually the optimal pseudocode that we can have for this condition. This is actually the optimal pseudocode, the most optimal pseudocode. Let's write this pseudocode. Simple. Build need from t, required the distinct characteristic. So required is a map which contain all the distinct characters in t. Okay, now we have 0, which is nothing but we have 0. The have, the how many element we need, have actually here is the condition that we meet, and windows count is the count of character in s. Okay, so left starting from 0 and then base is none. Here have actually checking the condition which we have, like it will check that if the condition or the constraint we are matching or not. In windows count we have the simply the count of the value at the string s, the using the character, and here we are actually taking character and count, which is integer, which is nothing but count. Now we just every time we just increase the s of right to window. So every time we add the value into the window, and if it's meet the condition which we have previously, like in t how many number of element we have, we just increase our have. Okay, and if any condition the have is matching the required condition, required is nothing but all the distinct characters in t. If the have is equal to the required character, if, and then the width, which is nothing but the current substring length, is become less than or the smaller than the best one, then we just have to just in change our base to the smallest element. Okay, because we have to find the minimum substring. Then remove the length and check if any condition it break the condition to have all the element of t, then we have to perform have minus minus and then left plus plus and then return our best window. So this is one of the best pseudocode. I tried many pseudocode, but this is one of the best one for this question. Actually, this is actually the best one. So try to use this and understand this. So now let's go to our question. This is our question. So first calculate the size, like int m equal to, actually mention here, m is the length of s and n is the length of t. So m is s dot size and n is t dot size. Okay, if any condition, we just, if any condition n is greater than m, then simply return as empty string. Why? Because suppose the, okay, suppose the s is a b c d e, okay, and the t is a b c d e r s w t. So we have to find every element of t into a. Also the frequency of element should also be same in the s, actually mentioned here in the question, including duplicates. That means the frequency of element in t is also become the same of the frequency of element of s. For that reason we are actually performing this operation, that if any time s size of s is size of t is become greater than size of s, then we have just return the element, return the string. Okay, now take have. The have actually give us how much we have to take, how much we need to fulfill the requirement. Okay, and a min length or minimum length or answer, which is nothing but at the starting integer maximum. Then we need a, a map which store all the value of t. Map to store all values of t. So first we take a map, unordered map, which is nothing but store character and integer of map. Then everything in the t, and in, and not take it as mp, take it as need. We need this amount of element, actually we need, which we actually need. This is our need, character plus plus. Okay, so we need this array, we need this map every time, so we store it. Now take the required, req, I take it as required. So it is nothing but need the size. If any time the size is matching, we should check it. It always left pointer at starting 0, also a start pointer at the starting 0. Let's discuss the start pointer later. Okay, so take a for loop for int r equal to 0, r less than n, r plus plus. Okay, so from the start towards ends, first get the character, which is nothing but s of r actually, and it's not m, and it's m, because s is, we take s as m, so you have to sure about that. So take another vector or window, a map to store element in element of windows. So take it as windows, unordered map, character and integer, which is nothing but a windows at the starting, and at the first add the element or the character to the window. So window of ch or character plus plus. Okay, now check that if in the T string, which is nothing but need of character, if any time how many the number of character we needed in T string is become equal to the value or the character at the windows or the current one, it means the number of element of the character in need or in T is equal to number of character in S. If anytime this is possible, have plus plus, nothing but just have plus plus. And now while have is equal to required, so we match our condition that how many element we need and how many element we have. We actually map that we need 4 element and we have 4 element. Now try to reduce the string length here so that we can get a minimum one. So for that, check if r minus l plus 1, which is nothing but string, is less than minimum length. If it's less than minimum length, just take it here and update the minimum length is nothing but r minus l plus 1. Also the start is l, so our length is starting from l. Okay, our length is starting from l. For this minimum length, our string is starting from the lth position. Okay, we just store our starting position here in the start. If it's not possible, then simply remove it and increase the L. But before increasing the L, we have to make sure one condition, which is to update the value if the need of S of L, the need of the value is greater than the windows of the value. Okay, that it means the value we need for the character is more in T and less in S. For this reason, we just go and remove our have by one step. Okay, then we just increase our L and go beyond this for loop and check if minimum length is equal to integer max, then simply we doesn't get any answer, so we just return a empty string. Otherwise, return the substring. The substring should start from the start and the size of the substring should become minimum length. Because if anytime we get a minimum length, which is the ultimate minimum length, but then we just remove our L or increase our L, so later we cannot get the starting point of the length and we have to return the substring. So when we have to return the substring in the substr function, we have to give the start and the minimum length. So for the start, we just store the value. For to ensure the start is always preserved, we store the value of start so that every time we get a minimum length. Okay, so just run it and submit it. It's working and it is as simple as that. So the time complexity will become big O of S and big O of S, big O of m plus n. M is the size of the S and n is the size of the T, and the space complexity is also big O of m plus n because we are using two maps. This is for S and this is for T. Simple as that. So this is big O of S and T, and also the space is big O of T because every time we are removing element from the start. So you can consider T or you can consider S plus T. Anything is possible here. Okay. So this is our question, minimum window substring. Go solve this question. Use this link. Use this link to get a 7-day free trial. Use this visualizer by chaicode.com at the dsa.chaicode.com. Thank you very much.